Okay, hi everyone. Thank you for coming to our roundtable this afternoon. We're going to hear all about how science can help cities shore up their climate adaptation efforts. As with our other press events, this will be recorded and posted on YouTube. And for journalists, any slides and other materials will be made available on the Press Info Exchange later today. The goal of these sorts of roundtables is just to have like a more intimate conversational setting, a little more back and forth, less formal, like, excuse me, I have a question for the panelists. So feel free to, pop in with questions and just make it your own and have fun. Yeah, I think with that, I'll just go ahead and turn it over to our speakers.
Okay. So I'm Andy Jones, and I'm going to kick it off. Can we go to the next slide here, please? Yeah, so I'm a research scientist at Lawrence Berkeley National Laboratory in the Climate and Ecosystem Sciences division, where I lead a program called Earth Systems and Society that is focused on the interface of climate science and decision making. And I'm joined by Abby. You want to introduce yourself?
Sure, I'm Abby Sullivan. I work for the City of Philadelphia. I'm the Chief Resilience Officer. Prior to working in this role in the Office of Sustainability, I worked at our water utility, and I've been working on climate adaptation for going on 10 years now.
Hi, I'm Naresh Devineni. I'm a professor at City College of New York. I work on water resources and hydrology, and more intimately on urban floods, and very closely with the city stakeholders on these things, and trying to look at extreme events and how those impact the current systems, what's the vulnerability, the whole sort of things like that.
Okay, great. Can we go to the next slide, please? So we're going to talk a little bit about the United States, but I also wanted to mention that cities around the globe are facing challenges related to climate change, and the Intergovernmental Panel on Climate Change is actually commissioning a special report on cities and climate change, and the lead authors for that are being appointed right now. I just found out last week that I'm going to be one of the lead authors on that report, and so over a 2-year cycle, the IPCC will be developing this report to synthesize the science of what is known about cities, the risks they face, and the adaptation options that they have. And so, and we know that, in the United States, almost 90% of the population is expected to live in cities soon. Also globally, that's 68%. So cities really are this place where most of the people live. And so that's an important place to look to understand the risks that we face with climate change. Cities are also a big source of greenhouse gas emissions. A lot of our industry and activities can be traced back to cities as well. And so the choices that are made, the way that cities develop in the future, makes a huge impact both on how we're affecting the climate and also the risks faced by people. I also wanted to mention that cities are also a place of innovation and creativity. And so they're also a place where hopefully that can become incubators of solutions for climate change. And it's really important that solutions that are identified in different locations can be transferred and learned from and adapted by other cities. So yeah, let's go to the next slide. I'm going to talk a little bit about, so as an overview, what role does science have to play? And, science isn't always the limiting factor to action for cities, but it's an important part of the story, in particular when it comes to facing novel threats from climate change. So one aspect of the research that's important is understanding what those risks specifically are related, whether it's related to extreme heat or flooding, electricity system disruptions, et cetera. But then going beyond just studying the risks to understand if we develop in this way, or if we develop in that way, what will be the implications of that? What would be the trade-offs associated with different adaptation pathways? So that's an important area that I would say is kind of growing for science. And it's really important that the way that we conduct this science is done in collaboration with the practitioner communities, folks like Abby, to make sure that the things that we're studying actually are the things that are going to be helpful for people who have to implement solutions. So can we go to the next slide? So in terms of understanding the risks, this is an area that my group has been working quite a bit on at Berkeley Lab. So one thing that we think about is how do we develop climate models that are tailored for understanding decision relevant phenomena. So we originally built these global climate models to understand global processes, global feedbacks, how's the Earth system changing, but in order to provide actionable information at the scale of a neighborhood, there's really many different processes that need to be considered. And so we've been working on downscaling our models to that very high resolution. And then when you get to that level, the feedbacks between the urban environment, the built environment and the actual atmosphere and hydrology, the way that water and heat move through the city are very much influenced by the urban form. And so it becomes important to understand these feedbacks at the small scale. Another aspect of this is understanding water and energy systems. So one of the key risks for cities has to do with our infrastructure systems that supply water and energy. And so knowing both how changing environment poses risks to those systems, but also how our adaptation solutions would potentially increase or decrease energy demands, things like that. Yeah, and maybe that's enough to say about that for now. We want to make sure there's plenty of time for discussion. So going on to the next, and I mentioned before, there's go ahead. Yeah, a recognition that we need to not just understand how extreme events are posing risks in urban environments, but also to be able to analyze adaptation solutions and understand their pros and cons, et cetera. And I'm going to let Abby say some things now.
Yeah, I think it's a really great topic. I think there's a lot of challenges when it comes to adapting to climate change in a city, especially one that's growing and changing all the time, while the science is changing all the time. You know, there's a lot of things about the city where I'm from, Philadelphia, that make us particularly vulnerable. So some of them are just sort of our location and where we are geographically. Being at the bottom of a watershed makes us much more susceptible to flooding. We have a really old history. So our history of the built environment, we did things like cap over our rivers and creeks and turn them into our sewer system. So if you look at a FEMA flood map, you won't see any flood risk in the middle of the city, even though we have lots of pluvial flooding, and that water's trying to go where there was once a river or a creek. So there's the history, there's our location and geography and sort of climate zone that makes us vulnerable. And then there's also that social component. So we have nearly a quarter of our population lives below the poverty line. And so that also makes people very vulnerable. And also related to the history is really old housing stock. That also makes it really challenging. And I see some nodding heads. I think this isn't a unique thing to Philadelphia. I think it's lots of old cities across the world face a lot of these challenges. But I think it's very complex. I think there's some really good things that can happen with density, right? Especially when we're thinking about energy efficiencies. I think there's some really great work happening in cities, pushing for local ordinances to have things like white roofs. But I also think that density, you know, tends to exacerbate a lot of these issues. And so we are paving over everything, covering it up with pavement and taking away ecosystem services, right? I mean, we're paving over what once took the rainwater and filtered it and absorbed it into the ground. You know, we've killed the mussels in our freshwater mussels that used to filter the water. We now have these combined sewer systems. Well, we've always had them, but they're, you know, exacerbating water quality issues. So it's just a really complex system. And I think what I would say is I'm really lucky that I got my start at the water utility in Philadelphia. I think it's one of the best utilities in the nation, and they have always done a really phenomenal job. They have their own what we call like watershed department, and we do a lot of our own modeling. And I think it's an institution that really bases all of the management decisions that are made on science and on, you know, sound science and modeling work. And so I feel really lucky that I got my start there. We didn't really have the counter in the Office of Sustainability doing that for the entire city. And I think that's a really big challenge, is that climate change is going to impact every single department in the city. So our health department, I mean, public health impacts of heat are, you know, well-known, really challenging to address. Our Parks Department, you know, if the seasons are changing, that's gonna change staffing requirements for lawn mowing. Vectors changing can, you know, have impacts on the staff that they're hiring. I mean, it's endless, the amount of impacts across all of these departments. And so I think it's been really challenging in Philly to get sort of citywide coordination where we're all using the same projections and downscaling, and we actually have training for staff to know how to choose a projection. So I ended up shifting into the Office of Sustainability, I think, to bring some of that sort of tools and those tools and that focus citywide. I've been trying really hard to do that. And a lot of that means partnering and working with researchers, with universities. And I also don't want to leave out the consultant community because I think they're actually driving a lot of really great adaptation work as well. So I'm trying my best to bring this to the city and bring tools citywide so that every staff can say that they're working on climate change in whatever sort of focus area they have. I think there is a real lack of sound risk information. You know, we don't have a great data set for pluvial flooding. So we've been purchasing it from First Street Foundation, and I know that can be a little controversial, but until we have the resources to do that sort of compound flood modeling across the entire city, that's the only thing we've got. So I think, you know, we don't have modeling that shows where storm surge will go on top of 1 foot of sea level rise or 3 feet of sea level rise. So we're just lacking this information. And so I think working with researchers is a very, very important thing that we're committed to doing. And I think an exciting thing is that we're working on developing a research agenda so that when researchers reach out to us, it's not them pitching a project always. It can be them looking through our agenda and aligning what they're trying to do in the research that they're doing to what the needs are. And one quick example I'll give, and maybe I'm going on too long, but you know, there was a researcher, I won't say who or where they're from, but they really wanted to work with us to develop an app to identify which, you know, neighborhoods and which homes are most at risk for like extreme heat. And I was just like, we don't need that. We know that it's our poorest census tracts. They're in old housing that doesn't have insulation. They don't have access to air conditioning. We already know where those places are in the city. We know those communities. We know that immigrant communities coming in are, you know, a big vulnerable population. So I didn't see a real need for an app when we have a lot of that information. But now I'm working with that same researcher to do microclimate modeling of extreme heat, but it's going to look at those solutions. So if we do build out a neighborhood with trees and cool roofs, how does that impact the urban heat island and the temperatures? So I think it's really just aligning the needs with the great research that's happening.
Yeah, so I can add to that specifically for New York City. The city, I think, is well staffed with hydrologists and hydraulics scientists. And one of their main challenges are they have the hydraulic models. They're trying to look at traditionally where it will flood and how the storm sewer systems will behave. But they're still looking for what is the modern climate information. Like in the future, how this climate will change. As Andy was mentioning, most of the climate information is at a very high resolution, very low resolution, meaning the entire grid covers the city. But if you look at within the city, the rainfall distribution, for instance, when it rains heavily, it may not rain heavily across the city in all places. There are places in Brooklyn that might get flooded only while the rest of the city is not getting rainfall at all. So this idea of spatial variability becomes very important, and that's where the high resolution downscaling of the models is very critical, especially how these trends will change in the future, which parts are much more vulnerable than the others, and do we have the sewer systems prepared for these emerging storms or emerging flood types of storms. That is one of their critical aspects they're trying to look for. And we have a partner project with them where we are closely working with scientists from the city. So these are our stakeholders, and they come up with these interesting questions in terms of what are their future challenges and what can we do as climate scientists and engineers to find a co-solution between them. So it's like a co-produced research, so to speak, where they have these interesting questions on how to solve cities' problems for the entire population. And then we have these climate models, we are trying to downscale it and then trying to find both space and time, because most of the times you have data from the daily time scale, but especially for hydraulic models or stormwater models, it's useful to have it at a sub-daily time scale. So if you have hourly rainfall, because most of the times if it rains, 3-4 hours it peaks, and then you get the storm flood from that peak. So having a daily rainfall versus having sub-daily rainfall also becomes critical. So the downscaling has space and time. So how do we best do them and how do we convey this information to them? It's something we're working closely with them. So that has been fruitful because this partnership, because of this co-produced research, they're showing us how their models are run and they're experts on them, but they're trying to look at what is the thing that they do not have that as the scientists we can bring into the table. And then we have things being done with that. So so far it has been fairly productive. We've been able to create some flood models under future conditions and look at what is the historical risk versus under these new emerging storms, how has that risk changed? And will this change in the future with as more storms like Ida, which happened in the New York City area recently? As these things keep emerging and happening more, how should the city adapt to these things? Should they add more green infrastructure, like Abby was mentioning, or should they work on replacing the drainage network, having more pipes, new pipes and all like that. So there's green versus green infrastructure kind of optimization things that we're thinking about.
Yeah, go ahead.
Yeah, I would just add, and this was a point from a session I was in yesterday, I think, the adaptation field is relatively new and the science is changing so rapidly that I think there is a big question about climate services. There's practitioners or, people that are making decisions at a city or a municipality. And then there's, people doing like real hard science, and then in between, is it on the practitioners like in Philadelphia where we're trying to have some of that expertise in-house? Or should there be a boundary spanner? I mean, there are some boundary, organizations, but, to me, they're not well enough funded. I think in Australia, they call it knowledge brokers. I think there's kind of a missing link that we don't put enough focus on, and I don't know. Yeah, I don't know if it's like social science fills that niche or if it's the federal government and sort of NOAA has a lot of climate services they provide. So do we expand that? But I think we need to identify like where climate services should be coming from and help standardize it across the country and the world, because there's a lot of places that have no resources to even begin to think about this and try to unpack really complex science and dealing with uncertainty and making decisions under deep uncertainty.
Yeah, so I think for that, questions as there are.
I have one. You said that in 2050, 90% of people globally or in the United
In the
States are
US.
living in cities.
In the United States.
So I guess I'm trying to understand, based on living in DC and those other areas, what defines a city? Because it doesn't stop at the border.
Mhm.
Is it suburbs as well? What is a city?
Yeah, I would imagine for that 90% number that it's including suburbs. Yeah, so there's a gradation of, and 6 cities are kind of, it's a squishy term, it's like they have political boundaries, but they also have, social and infrastructure and economic boundaries that are harder to circumscribe.
Yeah, so in New York, we have greater New York, so it's New York City, parts of New Jersey and Connecticut. Still urbanized, basically. So that still comes under the greater New York City area.
Well, and you were talking about a lot of people that are most at risk live in these older buildings. Are they things that we can prepare for the future, or do they have to be replaced? I mean, can you fix them and make them sustainable in 2050?
I don't think there's one answer. I think in some places, like we have one neighborhood where the houses were, through urban renewal, they were built in the 1950s. They should have never been built where they were built. So those, I would say, if there weren't other complicating factors, we would say people shouldn't be living here. It's too risky. but that's people's homes, and so you can't just do that. But, we are trying to set up services for them. If they want buyouts, they can get them. We developed a flood ready homes guide for that housing type specifically, that 1950s housing stock that are connected. Other parts of the city, I think it depends again where you are, but I think there's historic districts where there's other unique challenges, but we're never going to get rid of some of those historic districts. I shouldn't say never, but I think we'll do a lot to protect certain places. But I do think with the changing risk profile, there are some parts of the city that just are getting to be too risky to live in, so.
I think there's also just questions also of who bears the cost, right? At what cost are you willing to pay to upgrade things? And, there's a compelling story of this potential win-win, right? That one of the solutions for reducing our greenhouse gas emissions is to electrify homes. And then the heat pump technology provides an efficient way also of cooling. And this is true, I come from California, and there's a lot of people who currently do not have access to air conditioning. We're going to need it at some point because it's getting hotter. And so there's this possibility that you upgrade all these homes and you can both reduce emissions and improve resilience to heat, but it's expensive. So from a policy point of view, how do you make that work?
And right now, like in Philadelphia, natural gas is still cheaper than electricity right now. So that's a really hard thing. We have an energy poverty alleviation strategy that my colleague developed with a team, but it's trying to do exactly what you're saying. It's trying to say, our poorest neighborhoods are also dealing with energy burden. Can we improve their housing stock? Can we get them heat pumps so that they're resilient to extreme heat, but also not emitting all these greenhouse gases? But yeah, it's really hard. And on top of, these reverse incentives with natural gas, there's also a real shortage in the industry for solar installers. There's just a lack of, so there's a workforce development opportunity there. And we are setting up programs, but there's even just a lack of, people you can hire to do some of these changes and that know how to work with heat pumps. So.
And heat pumps have their own risks with the freon that's used to cool them. And if there's a leak or something, then what's the trade-off of your having saved for the climate versus now you have a freon in the atmosphere. So there's that.
Have you guys gotten requests from cities? Are you working with certain cities on the model and stuff?
Yeah, so we do a lot of work with City of Los Angeles is this case study city that my group does a lot of modeling of. We have engaged also within the Bay Area. There's something called the Climate Readiness Institute, which and the Bay Area Climate Adaptation Network. So it's a group of municipalities and public sector agencies that are working on climate adaptation. So we do a lot of outreach with them and communication with them.
In New York City.
And then New York, yeah.
And you're saying city has its own models?
Yeah,
Or
so
you're
they have
saying-
stormwater models that they have in-house.
Okay,
The input to those are these rainfall data sets or hydrographs, these are called. So they have historical versus synthetic hydrographs that they can simulate and look at how to input them. But you can also think of under the future climate, what would this rainfall look like? And if that was forced into these stormwater models, where would the flood come out?
and you're helping them with that.
Yeah, so we have a piece that looks at, how to set up those models under these different types of rainfall scenarios and look at changing risks for different type of events.
And you guys are buying data.
No, we also have our own H&H modeling team at I think because it's the city-owned infrastructure, they're actually, so they're the only entity that really has that information. So we kind of have to own it and do that modeling. And we really struggle also with getting global climate model output at a sub-hourly time scale to feed our models to understand where the system is, we know where it's undersized, but where that flooding would occur and what that would look like. But we've come up with novel methods to downscale that information and fix that temporal issue. We've also come up with a method to have the projections reflect our precipitation patterns, because that's another thing global climate models do, is they do what's called the drizzle effect. So they kind of, the average over the year will be great. It matches perfectly, but it says that it drizzles every day, as where we get these like massive, crazy, big storms. So we also have that in-house, and I think that's been a challenge, is a lot of researchers want to work with us and get access to that drainage system information, but there's like, I think it's really hard to share. I mean, how do big H&H model, I'm not a modeler, but I think that seems like really challenging to share that information, especially detailed versions of it. And then also, there's just risk with like security reasons, you know, for like giving away information about your system. So I think that's a challenge, a particularly hard challenge.
Yeah. We've done a lot of work also with water utilities, so they're not, you know, they're not exactly cities, but they're the folks who are providing water to cities. And those have been really fruitful collaborations, I think in part because water agencies have a lot of hydrologists and engineers and, you know, people who speak that they are themselves boundary spanners in a way, right? So they're able to engage with the scientists, and they're very used to weather variability affecting the supplies of what they deal with. So there's kind of it's been an interesting entry point for co-producing some new science related to water resources. I think it's also worth mentioning the Department of Energy has these urban integrated field laboratories. So this is a new program that DOE has supported, that is a handful, I think there are 4 of them, 4 case studies, cities around the US where they have funded a pretty large research collaboration that involves a lot of public sector partners and academics to do both novel measurements and modeling in urban areas. So I think there's a Chicago one, Baltimore,
Texas, and
Arizona and Texas. Yeah, so it kind of gets to your question about what's a city. Yeah.
I mean, it's a city, maybe things that are densely populated, you know, because those suburbs are too, right? So city might be a misnomer.
Yeah, I know, and some of the sometimes we've been saying communities rather than cities. To capture, the city makes you think Manhattan.
Are there come 2050, are you gonna be able to walk outside and say, this looks different than it did in 2020? What are like the most dramatic things that would jump out and say, these are things that have been done? It's the white roofs, although it's hard to see.
Yeah. Yeah, I think, again, it's gonna be neighborhood by neighborhood likely, so that one neighborhood I mentioned that is very flood prone, it was built in a floodplain, it was built on top of wetlands, you know, I think there's a huge part of that neighborhood that was never finished with the development, and there's a lot of pressure to develop it. But there's also a lot of people looking at solutions to make that wetland storage again. So I think that could look a little different there. We're also working with the Army Corps to install a levee there. I think there's a really fantastic tree plan in Philadelphia that was led by our Parks Department, and it has a goal of increasing the canopy cover to 30% in each neighborhood. So it's not across the city, because already the canopy is not equally, dispersed. So it's this idea of reaching that target in all communities. So I think a lot more trees in certain places. We're in year 10, I believe, of our Green City Clean Waters program. So it's a massive green stormwater infrastructure program. We're the only city that has an agreement with EPA through the state for our long-term control plan update to solve our CSO problem primarily using green infrastructure. So there's massive green infrastructure, combined sewer overflow. Yeah. So, yeah, I think there have been slow changes happening. I think you'll see some infrastructure changes, but I don't know that if you just looked out your door that it would strike you, even if there's a lot of things that are in the works.
And it might depend on the neighborhood.
Absolutely.
Lower Manhattan, they are now installing flood walls for flood protection. So those who haven't seen that before, in 10 years, they can step out and I cannot see the front, but there's a flood wall. So this is like visually very different. And certainly there'll be more green spaces. I think will slow down the water flow and then eventually go into the pipe network. So I think in that sense, in 50 years or at least in 30 years, might look more green, but also more protected in terms of having protective walls around the flood control. Yeah.
And have we already seen some of that change over the last 25 years? I mean, this urbanization has been happening for multiple decades, right?
Yeah, I mean, I think one of the more dramatic things in terms of like visual striking changes in urban landform probably has to do with sea level rise because, you know, sea level rise is one of the slower aspects of climate change, but it's also kind of inevitable. And once it rises a certain amount, like you can no longer inhabit that space. And I think a lot of cities are thinking about what does managed retreat look like and trying to reimagine shoreline spaces. Can you create recreational areas that are designed to work with flooding? So those are kind of visually, I think, and they're also like iconic parts of the urban fabric already, like shorelines. People are drawn to the shoreline, and those are going to be changing. The heat stuff is a little more subtle, you know, and heat is one of those like extreme heat kills more people than floods or storms, but it happens, you know, quietly in people's homes, and so it's not as dramatic of a thing. And so I think the solutions may not be as dramatic either. You know, I think the city of Paris, your equivalent in the city of Paris I met recently, and they said their most important thing is that they have neighborhood you know, people whose job it is to check on their neighbors when heat is happening. And so it's really a social norm or a social practice is the solution, more so than a big infrastructure investment.
Yeah, and it's kind of similar, you know, the big talk in the last few years is resilience hubs. And like, as a city, we have cooling centers already for when it's extreme, when we have a heat event. So it's this idea of a resilience hub kind of came out of Urban Sustainability Directors Network, Kristen Baja from Baltimore. But, you know, we looked into it, like, could we get funding to really beef up some of our cooling centers so that they could serve as like an emergency shelter if there was a hurricane that hit? Could they have, you know, backup generators for power or, you know, solar in their own battery storage? And then another key piece is that resilience hubs have like programming throughout the year. So it's not just for an extreme event, it's also for workforce development. It's for educating people about checking on your neighbors and like, you know, improving that social resilience as well. But what we've learned from everyone is that really the most successful resilience hubs are community institutions that are community led, right? So people want to go to their church more than they want to go to, you know, the rec center, cooling center. People want to go to an anchor institution they trust that they grew up going to. So I think it's not to say we aren't looking at it as a city, but I think we're really supporting, we've done TA and grant writing support for community groups that are applying for funding to build resilience hubs. We're even, I think, selling one of our buildings to a community group that wants to turn it into a resilience hub. So I don't know why I went off on that tangent, but I think that's another interesting thing is that I think a lot of communities are becoming empowered and you're seeing much more like community level planning that does involve human interaction and
And there's a similar example in New York City. There's a program called rainproofing where the community actually comes together and they're trying to find out what are the types of solutions we can find for our neighborhood in terms of being resilient to floods. And the city sort of encourages these people to come together and they have a report that they generated recently. And eventually they keep doing this over several cycles. So you get feedback from multiple communities also. So it's like very involved program.
What's it called?
Rainproofing. New York City rainproof.
I'm curious, Andy, so when you know, at the origins of a relationship with the city of Los Angeles, for example, do they have in mind what their key, you know, problems are? drought, extreme heat, and they have some kind of idea, you know, of the tools that might be, the adaptation tools that might be available,
I think so, for
pavements
the
or
big,
whatever it is. That
Yeah.
makes you
for the bigger cities have Abbeys,
Yeah.
you know, they have chief resilience officers who are
Yeah.
thinking about this stuff. I think it's been interesting with some of the smaller community organizations that there's always this interesting, I think that's why we like the term co-production of science with practitioners and scientists, because there's different knowledge that each group is bringing to the table, and that you learn from each other and can riff off of the questions that each person, the different sides are raising, and get to new questions that you wouldn't get to otherwise. So there's, you know, we don't want to be coming in as scientists being like, hey, we know what you need, we've got an app for that. But I think on the other hand, it's useful for practitioners to hear like, oh, that's like the range of where precipitation is headed for my region. Like, that's really useful for me to know that, and that makes me think maybe we should be trying this. So I think that there's something really to be said for those conversations that kind of start from what challenges are you facing, and then seeing where that goes. Basically, we call it co-production. And there's actually a science of co-production. We could have invited Kripa Jagannathan, who is a colleague who works with me at LBL, and she's built her career around being a social scientist who studies how co-production happens.
production meeting between stakeholders and.
Yeah, so knowledge production between stakeholders and scientists. And then I think there's also an interesting distinction between fundamental science co-production and more applied research. And that we have a project called Hyperfacets that Naresh is part of, where we've been doing co-production with water resource managers. It's a fundamental science project, and in part because of the constraints of the funder, we have to bring it back to basic science. But that's actually turned out to be a really interesting constraint that's forced us to get to the deeper heart of the problem. So we have someone say, here's what I'm dealing with, and we say, well, what is that an example of? What's the underlying problem that you're facing and that other people might be facing too? And let's work on that deeper problem. And so it takes longer, and it doesn't give immediate results. So we have to manage expectations about what to expect in terms of a timeline of being able to deliver a solution. But it gives us the flexibility also, though, to change scope. Whereas there's also kind of in a more applied project, you have like a more clearly defined scope from the beginning, and a deliverable in mind already.
Realizable solutions that we're trying to get.
Yeah, I think it takes all kinds of co-production.
Yeah, I think co-production's really hard. It's really hard to do well. And I would just mention, I work very closely with a team of universities through an NSF funded project. The whole point of the project was to co-produce the research and make it useful. It's called the Megalopolitan Coastal Hub. I'm forgetting some word in there, but it's led by Bob Kopp out of Rutgers. And we've found that it's really, really hard because the project started, the funding came through, and it really took about a year to 2 years to even understand with practitioners and stakeholders, what are their questions? Well, there's students in the meantime who need to publish papers, right? Like the academic system doesn't really reward the time frame that co-production requires. And one student I was working with, we worked really hard to try to get this research project off the ground. And in the end, it just didn't work out. So that was really disappointing to them. They had wasted. I mean, it was useful, but they didn't get published for it. They didn't get, rewarded for it. They almost felt like so I think there's really tricky challenges with universities and the incentive systems. And, we were talking maybe these NSF grants should have a year first, where it's just understanding the needs before the actual research begins. So I think,
Yeah. I think that gets back to what you were also saying earlier about climate services, so that, you know, there are some problems where it's a really good fit between a university person or a national lab and a practitioner, and that's great, and we should work on those problems.
Yeah.
But there's a whole bunch of other problems where the incentives aren't, you know, so if I could help you figure out something you need to do and get a paper in Nature Climate Change, great. But there's a lot of problems that aren't Nature Climate Change
Right.
papers, and so having a professional class of people whose job it is to be applied climate service researchers or support
Yeah.
staff would be really nice. And there are some things like I'm also a faculty member at UC Berkeley, and we're spinning up a new master's in climate solutions, which is meant to train people like that who would maybe be going into business or, and you know, into private consulting, but make sure that they have the foundation in climate, not just climate science with a little s, but like the whole kind of climate space.
I have to run.
Yeah.
Thank you so much.
Thank
Yeah, sure.
Do we have any more questions? We've got just a couple minutes left. And yeah, I think we're good. Yeah, thank you guys. I mean, Andy, I just want to circle back to what you said at the beginning about just how hard it is to study like a living city that's changing in a changing climate.
Mhm.
It's like there's some animal that's running through the woods in the dark and it's blurry and you're trying to capture it with a net and you don't know what it looks like.
Yeah, and you live on the animal, so it's. I don't know.
So thank you guys for highlighting this.
That would have been a great quote in the
Yeah.
paper. So I hope somebody heard that.
Right.
Yeah, thank you guys so much. Yeah, go ahead, and wrap it up.
Yeah, thank you.
Thank you.